Hi, my name is Andrew McLaren, and today I want to talk to you about how we can use subscripts and labels with a consistent letter for a certain variable. Where we have, for example, forces, you can use F as a consistent variable and then have these subscripts on it. And you can kind of see right here where I've got F of N. That is my preferred way of doing it. So I really like to use this consistent F letter with different subscripts next to that so that it indicates what that force is, but it also helps us understand what we're looking at is a force. It's kind of like why we write units with numbers. It helps us have some context with what we're looking at. And a lot of textbooks, unfortunately, will use different things like N, not for newtons, but for this normal force. And then there's also like W, which is sometimes used for weight, which is F of G. It's that force of gravity. And there's all kinds of other things that you might see, like with like tension, where they'll give like big T, where they should be saying like F of T, because big T to me, that's not just tension that might be related to torque or time or period or temperature. There's so many different things that T could be related to. So when we're talking about the force of tension from a rope, it's important to use F of T. So you can see I've got a textbook right here. This is an online textbook, OpenStax, which is a pretty good resource besides the fact that they consistently use these letters to represent forces. You can see they've got capital N here and a lowercase w there because, that's how they clarify work is a capital W and the force of gravity is a lowercase w. I don't like it. It's really messy. It's very confusing for students. And then there's also things that they'll do where they tell you like, oh, you've got um, the weight parallel weight perpendicular, which is equal to some trig function, which is this m times g, which is very confusing to me because sometimes these can be going in positive directions. The force of gravity should be a negative number, and also this gets kind of like, wait, which one is which, perpendicular, parallel? So I prefer to use x and y prime for my new slope. There's like the x and y original and then xy prime, which helps me notate those new directions. So like subscripts are a lot clearer than this parallel perpendicular thing using x and y. So that's pretty important to keep in mind. Then we also have tension here, which they've defined as in this problem equal to W. So that's mg, whereas for me, W would be a negative number and torque would be a positive number. So I wouldn't say that they're exactly equal. I would say that they're opposite to each other. So there's some confusing things that you see in these textbooks and how they notate the various forces. Unfortunately, like this is just really, really weird and messed up because it's like, wait, what am I looking at? T, W, N. No, it's just force. Just use F and have some labels on that. So that's the issue that you see with a lot of textbooks. I've seen them, and it's a pretty even split, honestly. Some teachers prefer to use F with subscripts, and other ones prefer to use these different letters. And it just gets really messy and confusing, in my opinion. Also, if you Google what is T in physics, there's legitimately like a different answer um, from like everything right here. It's just completely nuts. How many different things can be represented by like change in T? Could be temperature or time, or they've got also like the period, which is capital T, I believe. Very confusing, right? So instead of using T, do F of T with that little subscript. That's a lot clearer. You'll also notice that I like to color code certain things pretty consistently. I'll have F of G be red and normal force be purple. Um, and then you can see right here, this is a force of some tension, but you could say string on the box or something like that. So I might notate what it is. Like this force is one thing acting on another thing. So I might have some um, more of like a story kind of in that subscript. And that's usually if there's an applied force. So applied forces might be like 1 on 2 or S on B, where it's like this is acting on that so that you know what is involved in that force. I've got a ton of other things where you can see this written out. This is relating to that force of gravity parallel and perpendicular. For me, it makes a lot more sense to look at this and say like, oh, that was my y. But now when I'm looking at mass one, y1 is here because you've kind of rotated a little bit that way. And then the other one rotates the other way. So now y2 for this other object has a different rotation, kind of like going the other way because we're looking at two different slopes that are almost perpendicular to each other. Not quite, but almost perpendicular to each other. And then you can see with that, if you've got these things clearly labeled, it's a lot easier to build your triangle from the related parts and figure out your trigonometric functions and how those relate, as opposed to just memorizing like, oh, the parallel one is cosine or whatever, because sometimes it's not, because sometimes they give you the angle of the incline, and then they might also give you the angle relative to the normal. So it might be like, they might tell you that, oh, it's um, an incline of 50 degrees, or it could be a rope that has an angle of 30 degrees from straight up. So you got to be careful with those angles that they give you there. And the best way to do that is just have clear, good labels, have clear, good diagrams, and that'll help you a ton with those problems. I also find that when I'm working with like static and kinetic, it's important to kind of keep things arranged like this for me with that original formula. I've got my force friction and that force normal. And you can kind of see how in this problem, I went through this with another student and um, just kind of noted how I would go through a stacked box problem. So you can see like there's two masses here, so I might do M total and then do force diagram for that whole thing, indicated by the dotted line going around the whole thing there. And I might look at it and calculate the acceleration of gravity and all these other things to help us figure out the friction that it's experiencing on a certain surface. And then you can do the same sort of thing for the individual boxes. And you can see how I'm using colors here to like notate the different work for the different boxes and show that they have the same acceleration, help you keep track of how those forces are related to each other. So this is a thing that I use a lot. You can see like I've got f of g of mass 1. So there's all kinds of things that you can add onto the subscript. Just keep on adding. And if you've got clearly labeled diagrams, you should know what you're talking about, right? And then I might do like MT, MB instead of M1 and M2. That could be one way of notating those different masses. If there's like a car and a truck, sometimes I'll do C and T. So there's all kinds of different tricks that you can do to keep track of what's what. I really should have my units with that acceleration value, but you can kind of see why this helps in these various situations. And like for me, just kind of coming back to this, like G is, I have issues with G being written as a positive number because it almost always is a negative number. So I typically will think of the acceleration of gravity and write as a negative number, and that also keeps the letter consistent. Because why are we using A for most accelerations, but G for the acceleration of gravity? And some people might be like, well, it's not what the object's actually accelerating at, but that's where it comes from. This is the acceleration if it was the only force. So I think it's more appropriate to write that as A of G. You can see that there's a lot of places that are similar to this where people will do a little bit of shortcuts or shorthand, but because they're doing that, it can make it a little bit unclear about what we're talking about in that situation. All right, thank you. Bye. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wisant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page, and our social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.